All right, so we have John Pascaret, right?
Yep,
You're VP of Product at Monolith. Could you give us a little introduction to Monolith on the product and kind of what it does and how it was founded from the Imperial College of London and just a quick wrap up of all that?
sure. Yeah, Monolith is an AI guided testing tool. And so what that does is it allows customers to build AI models from their test data so that they can understand how the design works, make predictions, and optimize the design. So fundamentally, where it adds a lot of value is in the validation step of kind of complex nonlinear designs. Think of anything that drives or flies. There's a lot of characteristics that you can't really simulate. And so these models allow you to kind of understand how it's going to work and help you streamline your testing. The origin of the company is pretty interesting in that Richard Offeld, our founder, while working on his PhD, he spent some time at NASA, and he was tasked with simulating the vibration stresses on a rocket as it goes through launch. And as you can imagine, that's a tough challenge. Traditionally, how you would do that is with math-based simulation. And so that required him to simulate every bolt, every joint, every surface of the rocket in these incredibly complex simulation that would take sometimes weeks to rerun when you'd make a change. So it almost was an impossible task. And while doing that, he realized that if you can take some test data from a prototype and build a model of the rocket, you can actually get a much simpler and more accurate understanding of those forces. And that's really where the idea was born, is building a platform to allow engineers to leverage test data to build these machine learning models to help you understand how your design operates.
Very cool. And I saw on the website that it takes it has a lot of data capability for just common data that engineers are going to be using. Can you talk about what sort of data that first off, that they could put into the software? What does it accept?
Sure, a monolith can handle a lot of different types of data. Fundamentally, it's tabular data that just includes the inputs and outputs of all of your test programs. And so that tabular data could represent anything, in terms of the different types of measurements you can make, electrical, physical, stress, strain, temperature, just, any types of conditions and design parameters around operating your product, and then the outputs that you measure, what matters most. And we also do support some 3D capabilities as well. So we can take CAD data and help you look at how designs respond to different forces. But a lot of that really comes down to whatever the key inputs and outputs are for your testing. You can load those into the product, and we can start to make models out of it.
Cool. And just as as we're in the intro part, what generally can be done with that data? What's kind of the first few things that engineers typically do?
Sure. There's kind of a common model for kind of going through a workflow where you load your data, and then there's a lot of tools for exploring the data to really understand what do you have, and some analytics on the data to know, do you have gaps in your data? Are there anomalies in your data that might represent issues or problems? Kind of just what is the nature of the data? Are there common values? What are the ranges of values? So you really understand what you're dealing with. And then there are tools to clean and transform the data. So you may have different waveforms that were acquired at different time sampling rates. You can kind of realign things to be on the same sampling rates. You can fill in gaps and so on. All of that is to prepare your data to then model. And so we have modeling algorithms to create a model that you can then use to make predictions around new conditions. So things that you haven't tested for yet, you can actually see how the product will react. And then ultimately also optimize. So you may have a product with different settings or conditions, and you can set some of them and say, okay, I need to optimize and find the best set of values that meets these conditions, and then the modeling will come up with the optimal values for your solution.
Cool. Of those, I guess, of those features, and maybe some others that that's capable of, what are some of the standout things, maybe top 2 or 3 things that engineers are like, oh, this is fantastic. This will save me so much time or make me so much more accurate or take care of, tedious work that we have to hire people to do?
Sure. I think one of them, which is a very kind of, you mentioned tedious work. We have some new algorithms right now that are anomaly detectors that you can think of as if you're making some measurements on a prototype, and it can be pretty complex. You can have literally hundreds or even thousands of sensors and signals that you're acquiring. There's a lot of opportunity to have bad data. You might have a sensor failure, you might have wiring issues, you might have scaling factors that are off. And for a lot of customers, you might go to a testing location, like a test track, wind tunnel, where it's a very high pressure, expensive experience to get this data. And so with anomaly detection, rather than kind of going back to the lab and then realizing you have issues, you can run the data you're acquiring through a model that will identify channels or signals that may have a problem. And so it really automates and accelerates that, potential for failures just in the data collection, which can be incredibly expensive. And, having teams go back to a test, have to rerun it, as you can imagine, costs a lot of time and money. The other big feature that's relatively new is it's called the next test recommender, which is, if you think about how people design their tests today, a test is a set of parameters and a range of those parameters that you have to sweep through to kind of test your design. So you can think of sweeping through, it may be temperatures in a temperature chamber. It may be voltages and currents and stresses and strains. And the challenge is, what is the right combination of those parameters and values that will tell you the most about what you need to know? And there's lots of different philosophies about how to come up with that test plan. But, a lot of people will do a full factorial. Well, they'll try to test every combination of every parameter, which may feel like it's complete, but it's incredibly expensive to do that. And so what Monolith can do with, once you have a model of your design, we can take some initial test data and tell you, okay, based on what I know, here is the next set of conditions or values you should test. And so it's more of an iterative process where you start with a little data and do a little testing, and then we guide you into what you need to test next to really explore the full design space, is what it's called, or the capabilities of the design that matter. And the bottom line is, if with these types of approaches, you can reduce the number of tests needed to run by upwards of 50, 70, 80%, depending on, the situation. And so this notion of using AI to guide your testing and your test plan can make your testing much more efficient. Or it can, if you may have the same number of tests, but you're covering much more of the kind of design space and getting a lot more done with the same time and effort.
Yeah, I could see that being really handy to get you to that, the Pareto principle, the 80-20 rule, helping you just explore that really important test and move on to the next one while not having to, test every single little tiny thing, slowing down your time to market, costing you money, and all that. So that's pretty interesting. I see that it's applied to several industries, but I wanted to talk more about EV battery validation. I know that that's your your highest growth market. Is that right?
Yeah, that's a big focus right now that got a lot of traction and interest. And for a couple of reasons. One, there, obviously there's a huge move to electric vehicles, which is kind of leveling the playing field. And so the business ramifications are huge. Batteries tend to be the most expensive component in an EV, and they actually define the value of an EV. It comes down to how far can I drive? What's the range? How long does it take me to recharge it? And how long will it last? Now, the interesting thing, with all of that pressure around the battery, the other side of it is technically batteries are incredibly complex. They have chemistry, electronics, and kind of thermal characteristics around heat that are all interacting in a very complex combination. And so you really can't simulate them. And so these EV makers are spending an incredible amount of time and money and effort testing batteries so they can understand how long they'll last. Are they safe? What's the best kind of profile to recharge these things so that you maximize the value and lifetime of the battery? So all these factors are going into these literally years of testing to really understand how these batteries perform over time. And so AI brings a lot of opportunity to kind of reduce the testing burden while also kind of increasing the coverage so you really understand how that battery will perform. So there's an incredible amount of interest and excitement around AI as the kind of the economic and business challenges are really pushing this EV battery challenge forward.
Yeah, it's really interesting. I also want to talk to you a little bit about the report that you guys released. So you contracted, was it Forrester Research?
Right.
And so you guys did a report on the state of AI in engineering, and AI is kind of the biggest, hubbub right now. And you guys had some really interesting points that they found. So the state mentions that inefficient testing exposes manufacturers to financial risks, most notably product delays, creating an accurate data-driven model after testing a prototype, and recalls due to quality issues. And those speak right to EV battery manufacturing. Could you walk us through a little bit on how Monolith could help the engineering teams solve those three problems?
Sure. I think the source of all of those challenges that you've mentioned comes back to how can you figure out and understand the performance of your design, whatever it may be, or the errors or failures in a design earlier in the process. I guess for many years there's been kind of a fantasy of we can simulate everything in software and never really have to test anything, and that'll streamline the whole process and tell us everything we need to know. And I think, engineering leaders understand that that's not reality, but the idea is still, kind of worth chasing, and where data-driven modeling comes into play is it allows you to understand and model the behavior of designs that you really can't simulate. And so it gives you another lever or tool to really understand the behavior and predict how it'll operate. Because as you go further down the engineering workflow, when you're building prototypes, that's very expensive, especially if you have to do multiple and if they're complex products. So the more rounds of that you have to do, the more challenges, the more risk, the more cost that come into play. And so our entire focus is on trying to give people these tools so that they can understand more and ultimately test less, but still have a kind of a better view of how the design will perform across more conditions.
Cool. Speaking on those teams that are using Monolith, how is it been received by the teams? Are they? I'm assuming that they really like it. What have they said so far?
Yeah, I think like any new technology, there are some companies that are aggressively adopting and trying to get ahead of the game, and there are others that are more begrudgingly kind of realizing we've got to figure this out or we're going to fall behind. So they come in all shapes and sizes. I think one of the things that we've seen is, there are a lot of particularly bigger companies that are investing in data science resources as well. And so you kind of have this engineering group that really understands the product and how it behaves, and the data science team that understands the math. And then there's a certain amount of translation that has to happen. And secondly, the data science resources can be scarce. I mean, they may not be available to help the engineers when they're working on a new design. So one of the things that people like about Monolith is it really brings the data science and the modeling to the engineer in terms and a tool at a level that they can use. It doesn't require PhDs in data science. It doesn't require to be an advanced programmer. It's built in a no-code environment that allows you to kind of very quickly pull your data in, understand the state of the data, and then build models and start making predictions and so on. And so that's where I think we see a lot of interest and excitement, is kind of unlocking the engineering department with a tool that's designed for them to really kind of accelerate this testing process.
Awesome. I wanted to talk a little bit about just general AI, especially with automotive manufacturing. It's really interesting right now because, if you look back at history, automotive manufacturing tends to not only lead the way in the way that we manufacture everything, but also tends to lead the way that we live our lives. We were obviously agricultural for a long time until we had the assembly line and Henry Ford and 40-hour work weeks and pensions and things like that. And then Toyota with lean manufacturing kind of changed the way that we make everything. And then now we've got Tesla with vertical integration, and we've got all these different kind of new smart factory, industry 4.0, all this new stuff popping up. AI obviously is part of that. So what do you think this is going, and what sort of challenges do you think we'll have along the way? I imagine that you probably would say that AI will become the norm within manufacturing within, I guess first off, the first question is how long until you think that AI becomes the norm in manufacturing? And then second off, what sort of problems do you think we'll have in that initial adoption phase?
Let's see. I think I think we're seeing AI pop up in a lot of areas across engineering and manufacturing today. In terms of the norm, I think you know, it's like a lot of things. Anything I could predict is probably going to happen even faster. In the next couple of years, I really see the ramp accelerating. Um, and in some areas like semiconductor, where they literally are creating billions of, the wafers that generate all of the chips, there are tools today that are somewhat AI-like, where they can understand after running tests on these wafers, if a test doesn't fail, over a certain amount of time, they just automatically kind of take it out of their test matrix. So in some ways, they're using the data there to kind of adapt in real time. In terms of, I guess, so I see the adoption happening quickly. I guess the challenge is, it really comes back to, there's been a lot of talk about, will it replace people? Is it a threat? And I really feel like, and actually a founder in a previous life came up with this analogy, so I can't take ownership, but it's very similar to in the financial space when the spreadsheet came out. And the spreadsheet not only made the financial experts a ton more efficient, it really opened financial analysis to the masses. And so it really became an incredible tool to drive efficiency and effectiveness in that space. And AI can do the similar thing here. I think people that are seeing it as a tool to get a competitive edge and get more efficient and more effective will get ahead. And I think it's really not about the threat. It's about the threat of falling behind if you're not taking advantage of it.
Yeah, that leads into my next question. You hear Sandy Munro from Munro and Associates talk a lot about the paradigm shifts that we've seen, especially with when he was working on automotive manufacturing in the 70s and 80s. We saw Japan come in with lean manufacturing and just better, cheaper, more efficient, more fuel efficient cars, and just destroyed a lot of our domestic car manufacturing. I live in South Bend, Indiana, and
Sure.
Studebaker in the 60s, they went out of business just because their cars were just not as good and they were too expensive, and just a big deal for them. It just took them totally out, and they aren't the only ones. There's several like that. And do you think that we are kind of in a new paradigm shift with AI? Do you think that if the companies making cars or batteries or tier ones of any sort don't adopt AI for whatever reason, do you think that they'll be sort of left in the dust, sort of like we've seen before?
Well, I think it's a tool that will enhance your competitive position. So is it the only factor that will kind of dictate success or failure? No, but as we talked about with batteries, as market forces are so strong, and the competition and the fact that the playing field has completely been leveled in automotive, one of the challenges there is that, the battery supply chain is pretty concentrated in China and Chinese companies right now. So there's a lot of forces driving this investment and development of battery labs in Europe and North America. So I think AI can be a tool to help bring those up more quickly, and really just support the competitive position that a lot of these companies have.
Yeah, I really think that AI is going to just ideally it makes everyone way more capable and for way cheaper, and then that whole offshoring manufacturing to other countries because they're cheaper will, yeah, like you mentioned, it'll just increase their competitiveness, and we'll be able to compete against that with AI. I really hope that smart factories and AI and Industry 4.0 brings all the manufacturing back. We're starting to see some of that roll out with all kinds of new battery, either startups or
Hmm.
Car makers making their new factories, Hyundai and all the others making big investments. So I really hope that AI is one of the vectors that helps kind of move it along. Um, Speaking on China and battery manufacturing and AI, how far do you think that they are versus the U.S.? How far do you think they are? How far along do you think that they are using and implementing AI in their manufacturing, especially for batteries versus us?
Well, I don't know if I could generalize at a regional level. I think it's like anything. There are companies that are more competitive and using AI more aggressively, and then there are others that are playing catch up. And so, and that kind of applies across the board, across industries and regions. And so it's really as the kind of the hype around AI kind of at a consumer level continues to explode. I think it's dragging more people into this realization that they have to understand how it can help them to be competitive. So yeah, there's lots of opportunity. There are people that are embracing it and getting out ahead, but there's plenty of other people that are learning now and playing catch up, and there's lots of opportunity.
Yeah. Um, okay. Cool. So I just have one more question about Monolith, but is there anything else you wanted to speak on about the product itself? Anything else we should know?
Well, I think one point that's critical is that we've talked a lot about AI and what it can do for you, but it's similar to even the kind of the chat GPT generative AI topic of it's garbage in, garbage out. And so when you're talking about engineering, machine learning, it all comes down to your data. And so there are companies that have kind of a more mature strategy and understanding about how they organize and kind of reuse their data across different generations of products and different product lines. And there are others that are, just the fundamental challenge is they don't really keep their data organized in a way that they can take advantage of it. And so, that is another big, I think, vector that companies are trying to understand and are rushing to kind of realize, hey, we've got gold in our data, and we've got to make it prepped and ready to be used in modeling. And so that's just more of I guess, a trend we're seeing or a realization in order to take advantage of AI. And, we don't necessarily do that for them, but we obviously understand all of the kind of caveats and issues around data that's required to generate the best models. And so we do a lot of kind of suggesting and training on what are the factors that are going to make your data useful.
Yeah, we often see companies who are like, oh, we want to do smart manufacturing and we have all this data, and they're like, oh, it's going to be so easy. We just plug it in and kind of get some answers here, and then they find out like, oh my God, none of this data matches up in any way at all, and it's when we created this data, it was not made for this purpose, and this is going to take us, a year or two just to figure out how to put this into some sort of machine learning model or something. So that's like the most common thing that I've heard from companies wanting to get into the whole digital manufacturing sort of.
Exactly. It's, the digitization of your enterprise in general is what allows you to move much more quickly with something like AI when it comes onto the scene. So those forward-looking companies will be able to leapfrog very quickly.
Cool. And then my last question, I like to ask every company this: where do you see Monolith in 5 years? So 2020, we'll call it 2029.
Wow, 2029. hard to wrap your head around that number, isn't it?
I know, yeah. When it's coming out of my mouth, I was like, oh my God.
Well, as I mentioned before, we see a lot of opportunity right now, and where our primary focus is in design validation. So it's really a subset of the engineering product development process, and we see a lot of opportunity to kind of expand into further up into the design process, as well as further down into the manufacturing process optimization. And if you think about it, another sort of holy grail for the designers of the world is, when it's time to design a new product or a new version of a product, you're going to start with new requirements. And wouldn't it be great if you had a database of existing models that tell you how your full fleet of previously designed products operate under all these different conditions? And with that at your fingertips, you can actually start to kind of design the product at a much more detailed level using AI, because you know how different aspects of the design react to different conditions and different values. And so, that we see the benefit of using your data to build machine learning models, starting in test, because that's where the biggest kind of cost and risk and efficiency opportunities are. But ultimately, it can feed back into the ideation and kind of product design stage. And so we see a long, healthy roadmap for AI opportunities in the engineering space in general.
Cool. Well, John, I really appreciate you taking the time out to do the interview. It's a really, really interesting topic. And anything else we should know? Anything else you want to throw in there?
Well, I guess I'll ask James, did I miss anything? What else? I think we covered a lot. I appreciate the time and the questions, and I can't think of anything major.
I think you covered a lot there, John, and obviously thanks for all the questions, Jeremy. It's great to see you're so interested in the business, and just really appreciate your time, both of you, really. So thanks very much.
Yeah,